Hey everyone, I just want to welcome you to chemistry and to our video series that we're going to be doing this semester to help us to learn the material that we need to learn and the types of calculations that we're going to be doing throughout this semester. So today we're going to start out with math review, which is what we were supposed to be doing over the summer if you did that. Hopefully you did, and hopefully you learned something or remembered something that you learned before. But either way, we're going to go ahead and we're going to talk about some different things that you'll see this semester, such as just a brief review of algebra and the importance of units. So let's go ahead and get started. If it will switch the slide for me. Okay. All right, so the purpose of these videos and the quizzes that are following them up is to help us to be able to work at our own pace and to be able to take notes as we need to and to pay attention the way we need to. Because oftentimes in class, students are not paying attention, not really taking notes, and then scribble them all down at the end. I want you to be taking good notes as you're watching these videos. And if you miss something, rewind it, pause it, watch a different video, do whatever you need to do to make sure you understand what's going on. You can always ask questions. Work at your own pace. And also, I don't want us to be wasting time that we could have in class to be practicing problems, time that we could have in class to be doing labs and things like that. So if you need to take longer to understand lecture material, do what you need to do with these videos and with other videos that I can supply to you as resources. The quizzes is so that I can observe what things you're understanding, what things you're not understanding, and also allow you to be more prepared for class because you've already had to turn your brain on, you've already had to think about this material that we'll be practicing in class. And so the weekly videos will contain the class content, but they'll also contain some examples of problems and so on. When you are finished watching the video, you'll move on to the quiz, which will also be located on Schoology, and you will answer the questions to show that you completed the video, but also show that you understood what you saw in the video, and you'll be able to earn an easy grade by doing that quiz. Otherwise, you get a 0 for the video quiz combo. Okay, so just to get started, let's talk about units really quickly. So units are something that are included in science all the time, but they're also included in your everyday life. Because if you don't tell me what unit you're using, I don't really understand what you're talking about. If you tell me you ran for 5, say, okay, you ran for 5 what? 5 kilometers, 5 miles, 5 seconds, 5 minutes? I have no idea what you're talking about. So they're important because they tell you, they provide information to give numbers meaning. Okay? And you must use your units as you're carrying out calculations to help you to see what the unit should be at the end of your problem. And that allows you to verify whether you did the problem correctly, if your units are being carried correctly. So an example of this is if I had a 5.2 kilogram weight and something happened that moved at a distance of 2.9 meters, and we have 2 different times here. We have 18 seconds and 1.3 seconds. Now we can go through this and we can cancel, oh, this shouldn't say, oh yes, we're right. We can go through this and we can see what cancels in our units. Otherwise, if we can't cancel any units, they're going to carry to the answer. So, in order to cancel units, you must have that unit divided by the same unit, and then that will cancel. If they're not divided, then they can't cancel. So in this case, we have kilograms times meters. Those aren't canceling each other. We have kilograms over seconds, nothing cancels because the top over the bottom means division here. If kilograms was really seconds, then this seconds and this seconds could cancel, for example. Meters over seconds doesn't cancel either. So in the end, the unit for this should include kilograms times meters over seconds times seconds. And we recall that when we do anything times itself, that's the same thing as squaring. So seconds times seconds means seconds squared. That's going to be the denominator, and in the numerator we're going to have kilograms times meters. So let's verify, hidden behind my hiding block, that that's the unit we have, and that's what we see here. We see kilograms times meters over seconds squared. Now in order to get this number, we have to actually multiply out the numbers on the top, multiply out the numbers on the bottom, and then divide the answer from the top by the answer on the bottom. And we could work that all out, but we'll do that a lot this semester. So we'll focus on units for the moment. Okay, next problem. We have kilograms times seconds over seconds times seconds. Okay, now the rule here is if you have the same unit divided by itself, you can cancel it. But just because there are 2 seconds here and 1 second here, doesn't mean we can cancel all the seconds. If you have 1 second in the top, you can only cancel 1 second in the bottom. If this said seconds squared, then we could go ahead and we could cancel both of them. So there's a little bit of rules, but we need to follow the rules of algebra for the number of each unit in the top and the bottom here. So we can cancel these 2 seconds, whoops, and that should leave us with the answer of kilograms over seconds for our unit. And let's see that that's what we got. That is indeed what we have, kilograms over seconds. And again, we would have to multiply the top 2 numbers, multiply the bottom 2 numbers, then divide the top by the bottom.
Faculty and staff, please make plans to meet back in the media center
Okay,
at 2 o'clock this afternoon.
next thing we're going to discuss really quickly is simple algebra problems. And the first topic in simple algebra problems is addition and subtraction of variables, or problems that contain variables and numbers sometimes. So in this case, we're just looking at variables. We have x, y, and z as our 3 variables. And if we have an addition sign, our note here is that we will perform the opposite operation to be able to move variables to the other side. So if we have addition, we're going to have to use subtraction. If we had a minus sign here, we would use addition to move something to the other side. What I mean by that is if I want to get x by itself, if we think about this as 2 sides of the equation, let me draw a line. If we think of this as 2 sides of the equation where the line is at the equal sign, if we want x by itself, x is on the same side with y right now, so obviously y needs to get out of the way, it needs to move to the other side. If we're using the opposite operation, that means that we will be subtracting y on both sides. That gives us x plus y minus y equals z minus y. Now we know if we have y minus y, that means that it's 0, so it doesn't exist anymore on this side. So we can just cross out our y's on the left side, and after that we will receive x all by itself like we wanted. So we have z minus y on the other side. Let's look behind the hiding block. That is exactly what we see. Okay, now applying the same situation to where we have a variable with 2 numbers. If we have x minus 24, what do you think we're going to have to do if we already have a minus sign? We're going to have to use addition. And we want x by itself. That's what it means when it says solve for x. That means we want x to be isolated by itself. So if we have minus 24, that means we're going to have to add 24 to both sides. Remember, think of this as 2 separate sides of the equation. So this will become x minus 24 plus 24, which we will see later that these 2 24s cancel each other out, and then 13 plus 24. So this gives us, the 24s cancel, this gives us x equals 13 plus 24, and we could go ahead and add up 13 and 24, and we would get x equals 37. And if we look underneath the box, oh, there is no box. sorry. Anyway, this is our answer. X equals 37. Okay, so we follow the same steps whether or not they're variables or numbers. If these numbers had units, we would have to understand that that's a unit and it goes wherever the number goes. All right, so this would be our answer for this type of question. Now, that's addition and subtraction. Let's look really quick at multiplication and division. So this is another 3-variable equation here, where we have one variable multiplied by another variable equal to the third variable. Okay? So, same rule applies. Opposite operation. So if we are multiplying, you got it, we're going to have to divide. So in this case, x times y, if we want x by itself, we're going to have to divide by what? Divide by y on both sides of the equation. Now remember our equation, I'm going to use blue this time. Our equation we can think of as separated at the equal sign, so that this is the left side, this is the right side. This is being multiplied, therefore if we want x to be by itself and we got to move y, we're going to divide by y. If we do that to this side, we have to do it to the other side, divide by y. That makes our y's, if we take something and divide it by itself, what happens to it? It cancels, just like we were talking about with units. Y divided by y, those cancel. And now we're going to end up with x equals z over y. All right, let's check, make sure that's what we got here. Oop, that's not what I meant to do. Let's see, arrow, move the box. We do have that. We have x equals z divided by y. Now, let's do the same thing we did before where we applied this to a equation that actually has a couple of numbers in it where we want to have x by itself. I know you guys have done this before. Let's just make sure it applies the same way. So if we have 24 times x equals 13, we're going to have to do the same thing. It's too big. Here we go. I'm going to do the same thing. Okay. This is being multiplied, therefore we have to do what? Divide. But we're looking for x, so that means we want to keep x on this side. So x is not the thing we're moving, the 24 is the thing we're moving. So we're going to divide by 24 on this side. If we do that on the left, we have to do that on the right. Divide by 24. Our 24s cancel because we have 24 divided by 24 on the left side, and then we will just have x. X equals 13 over 24. If your problem wanted you to find a decimal, you could go ahead and put that in your calculator and figure out what 13 divided by 24 is. Otherwise, this may be good enough for your answer. All right, so that is multiplying and dividing. Remember, if you have any questions about these topics, make sure that you bring them up to me as needed. Okay, now we can get a little bit more complicated and do rearrangements that have multiplication and division at the same time. Now what I'm talking about is in this equation here, you would see this in your summer assignment notes. We have pressure times volume divided by temperature, that's what those stand for, equals to the second pressure times the second volume over the second temperature. That means multiplication in the top, division this way. Multiplication in the top, division. Now we can rearrange these by doing the opposite operation, and we can take that step by step to make sure we're moving through it carefully. Now if we're going to do that to get P1 by itself, that means I want to move what? I want to move V1 to the other side, and I want to move T1 to the other side. And we can do both of those. It's pretty simple. All right, we can do that in 2 steps to get our answer. Now we're going to look in a minute, because a lot of you might be wondering, well, what about cross multiplication? We can do that as well. So we'll do that as a second strategy you can use for this type of problem. But first, let's look at the steps. If I want to get P1 by itself, I'm going to start by trying to get T1 away from P1 to be on this side, because I want P1 by itself. So I'll start with T1. So I've got P1, V1 over T1. Now we know if we want to get this to be away from the P1, right now it is being what? Divided into P1. So that means we have to multiply it. So I'm going to multiply by T1 on both sides. So P2, V2 times T1 over T2. Okay, on this side, this is really T1 over T1. What do those two do? They're divided by each other and they're the same exact thing, so they cancel out on that side. On this side, however, we have T1 divided by T2. Are they the same thing? No, they're two different temperatures, so these are not going to cancel. So we're going to now have T1 in the numerator of the right side. Okay, so let me write that out. P1 V1 equals P2 V2 T1 all over T2. Okay? Now, remember we want this guy by himself, so that means we have to move V1. V1 is right now being multiplied by P1, so that means we need to divide. So I'm going to go ahead and divide V1 on that side. If I do that on that side, I have to do that on this side, V1. Now over here, we got V1 divided by V1. Guess what? They cancel because they're the same thing. On the right side, we only have V2 over V1, so these are two different volumes. Those are not going to cancel out. So in the end, we will have P1 equals P2 V2 T1 over T2 V1. And this would be our answer for the rearranged equation where we have isolated or solved for P1. Okay, that's our step-by-step method that makes sure you really understand every step. It's very good to be able to do it this way, because if you can do it this way, I can see exactly what you're thinking, because you're showing every step, you're crossing things out. That's what I like to see. Okay, but we can also do this with cross-multiplying. So if we were to take the same equation and we wanted to get P1 by itself, so I'm going to write it out, P1 V1 over T1 equals P2 V2 over T2. All right. The first thing we can do is cross-multiply. So that means that these are together, and let me cross-multiply, and our T2 joins up with this side. Okay, so let me write that out. P1 V1 T2 equals P2 V2 T1.